This lesson is about rational inequalities. So here are the steps in solving rational inequalities. First, you have to write the problem with a single fraction on the left side and 0 would be on the right side. So you want to write this in that form, px over qx. Then we solve for the zeros of the numerator. So we equate the numerator to 0 and solve for the values of x that will make the numerator 0 and also solve for the zeros of the denominator. So when have these solutions, we're going to do a similar second part to our quadratic inequalities. We're going to take the solutions here and plot that into a real number line. Then we're going to construct the intervals and then select the test numbers to check which will satisfy the inequality. And then for those intervals whose test number satisfies the inequality, those intervals will be part of the solution set. Let's have the first example. So check, we have a single fraction and the right side is 0. So we get the zeros of the numerator. That means x minus 2 equals 0. We solve for this. So x is equals to 2. And then the 0 of the denominator, x plus 1 equals 0. So x is equals to negative 1. So these are the zeros. So if we plot that into a real number line, we have the smaller number is 2, the bigger negative 1, and the bigger number is 2. Then we make the interval. So this is negative infinity to negative 1, negative 1 to 2, and we have 2 to positive infinity. So we pick a test number that is in the interval. So in this particular interval, we can choose negative 2. We can choose any number. Okay, let's choose 0, and here 3. Now, we're just going to see if these numbers will satisfy those. So I'm going to do is I'm going to write down the numerator first and the denominator, and I'll just get the sign. So x minus 2, x plus 1, and then I'm going to divide x minus 2 over x plus 1. So I'm going to substitute negative 2 to the numerator and just get the sign. So negative 2 minus 2 is negative. Negative 2 plus 1 is negative. So negative divided by negative is positive. And then next we try 0, substitute to x. 0 minus 2 is negative. 0 plus 1 is positive. So when we divide these two signs, you get negative. 3 minus 2 is positive. 3 plus 1 is positive. Positive divided by positive is positive. So now for the solution, let's identify. We want this to be greater than 0. Hence, we want this side to be a positive number. So this positive results will be our solution. So yes, this is negative, no. And since this is positive, yes. So that means, again, all the numbers in this interval will give you a positive value for this expression. And then all the numbers in this interval will also give you positive. So your answer would be from negative infinity to negative 1 and 1 to 2. But if you look at the problem, we are going to also solve when will this be equal to 0. Okay, so you have to be careful here because you have two numbers here. Unlike for quadratic inequality, this is part of the solution. But take note here, we just want the numerator to be 0. We cannot have the denominator to be 0. Okay, so that means x equals negative 1 is not part of the final answer because that will make the denominator 0. So that would be negative infinity to negative 1. We're not going to include negative 1, but 2 is included because when we substitute x with 2, you get a fraction equals to 0, and we want to include that. So 2 to positive infinity. So in our inequality notation, that's x less than negative 1 or x greater than or equal to 2. Let's have another example. So we have a single fraction here, but our right side is not yet 0. The reason why we want to make this 0 is to just make the checking easier. Okay, so I'm going to have the 1 transposed to the left side, and then this becomes less than 0. So that means this whole expression, we want this to be a negative number. So that's why it's easier when you have 0 on the right side, because it's either this is positive or this is negative, than trying to figure out if you will substitute a number here, if that number will become less than 1. Okay. So let's try to write this as a single fraction. So you have to review your LCD. So I'll make this step by step. Okay. So write this down as 2 fractions. Okay. So since this is the same, I'm just copying everything. So in fraction, since I want this to be written as that has a denominator of x minus 4, then to be equal to 1, I also have to multiply the numerator by x minus 4. Right? If you simplify this, that would cancel out, and that's equal to 1. Okay. Then, since you have now a common denominator, we're just going to simplify our numerator. Let's continue here. So you have 2 minus 3x minus x plus 4. Please don't forget that you're going to also change the sign of this one. Okay, not only this one, but you also have to change the sign of this. So positive becomes negative and negative becomes positive. Then we have common denominator now. So let's just simplify similar terms. So that's negative 4x. And then 4 plus 2, that's 6. Okay. So we have written our question as a single fraction and the right side is 0. So the next step is to find the zeros of the numerator and the zeros of the denominator. So for those of you, I think you can easily look for the 0 of the denominator. So how do you find this? Negative 4x equals negative 6. Divide both sides by negative 4. X is negative divided by negative becomes positive. And we can simplify this. They are both divisible by 2. So that's 3 over 2. And this one, x is equals to 4. So we have two numbers here. We're going to construct the real number line. The smaller number is 3 halves. And the bigger number is 4. So our interval will be from negative infinity up to 3 halves, or that's 1 and 1/2, up to 4 and 4 to positive infinity. We repeat the same step here. We choose a test number. So let's just choose, you can choose 0 or 1. Okay, so 0 is easier to do. I'll just choose 0. So greater than 1 and 1/2. So that's 2. Then this is 5. And then we're going to take note, no? We're looking at this inequality to make our test easier. You can also do it here, but it's easier to check whether it's just either positive or negative. So what's the numerator? Negative 4x plus 6. The denominator is x minus 4. Then we're going to divide the numerator and the denominator. So when x is 0, 0 plus 6 is positive. 0 minus 4 is negative, so this will be negative. When x is 2, that's negative 8 plus 6, so this is negative. And then 2 minus 4 is negative. Negative and negative, positive. Okay, then 5 times negative 4, so obviously this is negative, but this is positive. So when you divide this, you have a negative sign. So what is our solution? Let's look at our solution. We want this number to be less than 0. So that means we want this number to be negative, less than 0. So our solutions are this negative. Yes, then yes. This is no. So that means we're looking at the numbers here. So take note, we don't want to have 0. Okay, so this will be 0, this entire fraction, when the numerator is 0. So that means 3 over 2. When you substitute it here, this becomes 0. So we don't want to include this because it's not part of the inequality. No, you don't want it to be equal to 0. And you don't want to also include 4 because it will make the denominator 0, which is undefined. So our final answer will just be negative infinity up to 3 over 2 union 4 to positive infinity. So it's x less than 3 over 2. You can also use union, x greater than 4. Let's have our last example. So again, if you look at the problem, you have an x on the right side. So we have to transpose your x to the left side so that we have a 0 here. And we have to simplify this fraction here. So you can have your LCD is, why do you have this as the LCD? Because this is just x over 1. So x plus 5 and 1, your common denominator is x plus 5. So this is the same fraction, right? So I'm going to copy 24. But for this one, since you multiplied your denominator by x plus 5 to get this, you also have to multiply this by x plus 5. So that's x times x plus 5. You can check your answer. See, if you cancel this out, you'll get x. So that means they represent the same expression. So we're going to distribute. Since they have the same denominator, I can combine the numerator. And again, don't forget the negative sign. So I can include the negative as part of the x. So that means I can multiply these two terms with negative x. Okay, so negative x times x is x squared. Negative x times 5 is negative 5x over x plus 5 less than 0. So we have achieved our first goal of having a single fraction here and a 0 on the right side. So the next goal is to find the zeros. So numerator, we want to solve when will this be 0, and the denominator, when will this be equal to 0? So for this one here, if you don't want to deal with a negative x squared, you can move everything on the other side. So if you move this on the right side, negative becomes positive. So this negative becomes positive and this becomes 24. Okay. So you can either do factoring or quadratic formula or completing the square. So what are the factors of 24? So we have 8 and 3. So it will take you some time. Okay, since this is negative, that means that one should be plus and the other one should be minus. Okay, then since this should be plus, that means I'm going to choose factor that is bigger for this. So you can do trial and error. I have done that. So this is 8 and this is 3. So it's correct, no? 8 times 3 is negative 24. And then when you add this up, do the FOIL, the middle term was negative positive 5x. Now for the denominator, your x plus 5 is equals to 0, so x equals negative 5. Okay. So we have the intervals here, negative 8, negative 5, negative 3. We can create this, and we choose our test number. So we choose numbers from negative infinity to negative 8, negative 9, negative 6, 0, and 4. Now, instead of doing this fraction, we can try to factor this, but take note, since we shifted this to the right side. So that factor is not exactly equivalent to this. So how do we factor this? So you have 8 times 3, and then you need a negative 5. So it's negative x plus 8 plus x. You can double check the doing FOIL and look for the middle term if you get negative 5. So basically, we just interchange no, the sign of this one and this one. But since if you interchange this, it's still 8 plus x. It's the same. But this one, instead of x minus 3, this is 3 minus x. So please be careful when you have this type of problem. We just move this to the right side to make the factoring easy, but this is not equal to this one. Okay, so here are the factors that we can use so that we can evaluate this. We have x plus 8, okay, 3 minus x. You can also write that as negative x plus 3. It's okay. And then x plus 5. And then we do the entire fraction. Okay. Then we pick the number here, negative 9. Okay, so negative 9 plus 8 is negative. Okay, we can do by row. Negative 6 plus 8 is positive. So since this x will now become bigger and bigger, so that means as I add to 8, the remaining ones will be positive. Hence the advantage of doing it by row instead of what we are doing by column. Okay, negative 9. So 3 minus 9. So minus minus becomes positive. 3 minus minus 6 positive. 3 minus 0 is positive 3. And then 3 minus 4. So here, this is negative. Then for the last x plus 5, negative 9 plus 5 is negative. Negative 6 plus 5 is negative. So you have 0 plus 5 positive, and this is positive. Then we multiply this to negative divided by negative positive. Then you have positive times positive positive divided by negative. And then these are all positive, and then this is negative. So for the solution, we want this to be less than 0. So that means this one is negative. So we're looking for numbers for this to become negative. So then these are the solution, negative, yes. And then this are not the solution because this will give us a positive number. Now you can also check when x is 0, we should also satisfy this one. Okay, so here is it. When x is 0, you get 24 divided by 5, and that's not less than 0. So see, this is not a solution. Okay, but you can do other test number. I just showed you 0 because it's easier. So what's our final answer? Take note that we don't want this to be equal to 0. So that means I am not after the zeros of the numerator, which is 3 and negative 8. So they cannot be part of the solution because if your x is 3 and negative 8, this becomes 0. So then our final answer will be, what's our solution? Negative 8 to negative 5 union 3 to positive infinity. And the other notation, that's x greater than negative 8 less than negative 5 union x greater than 3.